Thank you so much for putting your cell phone up there. Okay, so go to question number 1. If you don't have if you don't have a study guide, go ahead and grab one from the white table. We do have like maybe 3 or 4 left. All right, here we go. Shh. Number 1. Does a quadratic function open upwards or downwards? How can you tell? Always look at the leading term, and it's negative x squared, so it's a frowny face, okay? So when you have a negative up front, so this will have a nice little maximum. And it opens downwards, okay? And we have the negative x squared, that's why. This little guy. All right, sweet. So now we go to number 2. What is the axis of symmetry? Let's go ahead and split the parabola into 2 equal parts. It's a vertical line. X equals 4. What is the vertex? Go to the point there. You start at the origin, go to the right 4, down 4. Ordered pair. What's the y-intercept? You can't really see it, and I apologize. It was supposed to be 7, 8, I think at 8. On the exam, I'll make sure to put it on the graph. Okay, I'm 100% sure. What are the coordinates? The solutions. The coordinate points of the solutions or the zeros. It's 2, 0, and 6, 0. What is the domain? We always have negative infinity to infinity. What is the range of the function? Always look from bottom to top. -4 all the way up to infinity. There you go. Bless you. Is the A value positive or negative? You have a nice little smiley face. You are positive. Let's go to number 3. Use the graph below to answer the following questions. Again, same thing. I hope you were able to do this. X equals 2, 2, 9 for the vertex. The y-intercept is nice, 0, 5. What are the zeros? Oh, it's at -1, 0 and 5, 0. What's the range? Read it from bottom to top. Its arrows are pointing down forever, all the way up to the highest y value. Is the A value of the function positive or negative? It is a frowny face, so it is negative. Turn the page when you're ready. All right, for number 4, I think this is a good formula for you to write down on your flashcard, -b/2a. This is your axis of symmetry, okay? Identify your A, your B, and your C. Negative parenthesis, 6/2 times 3. Always, always, always put parentheses around the A and the B, or else you're going to get this wrong. So it's -6/6. Therefore, equals -1. Therefore, x equals -1. It's all multiple choice on the final, so hopefully you guys are able to select the right one. Vertex, all you got to do now is plug in this number in for the x of your in your original function. 3 and then parentheses squared plus 6 parentheses plus 4. Replace it with -1. You could do the math in your head. 3 minus 6 plus 4. 3 minus 2 is 1. So you get -1, 1. Okay? Therefore, y equals 1. What's the y-intercept? We know that all the x's are 0, right? Why all the x's 0 is because you're crossing the y-axis. So that means you get rid of all the x's in your original equation and you just get 4. The c value, 0, 4. The vertex is a minimum or a maximum. Well, let's look here. Are you a happy face or a frowny face? Look at the leading term. It's 3, +3, so you're happy. So you have a minimum. All right. Make sure you're writing this down. Number 5, same idea, right? Now see if you can give that one a try. I think a lot of you did. So I'm just going to go ahead and do it for you. You can check your answers here. All right, there you go. You plug this into your calculator. Go ahead and grab mine. All right, and we got 2. So therefore, we got negative 3 comma 2. Y-intercept is just the C value. 0 comma negative 16. And then are we smiling or are we frowning? It's negative 2. We have a little frowny face. So therefore we have a max. Okay, so hopefully you guys were able to get those questions right. Number 6, this one is just graphing. Same thing, I would write this on my flashcard. Use x equals negative b over 2a. That's always how you start it. You start finding your x coordinate of your vertex, your y coordinate of your vertex. And our b is negative 4 and our a is 2. Okay, so that's 4 over 4, which makes 1. Now we find our y. We just substitute. 2 minus 4 minus 4. 2 minus 8, negative 6. So that is 1 comma negative 6. Why did I put that vertex right in the middle? Well, because the vertex is the point that is right in the middle, right with the axis of symmetry, where it splits the parabola into 2 equal parts, left and the right. So it's good to put it in the middle. All right, so now we look at what's the next number after 1. It's 2, and the next number is 3. What about the number before 1? 0 and negative 1, right, if you're going backwards. I think this is what a lot of students miss, so make sure you're paying attention. The next thing you're going to do is just substitute. Same thing, same to what you did with the vertex to find the y. You're going to plug in, okay, instead of x, these are x equals 0, x equals, we're going to substitute x is 0. 2 times 0 squared minus 4 times 0 minus 4. This is equal to negative 4. Since it's a mirror reflection, this guy's also negative 4. Now let's use substitution for this one. I'm using the easy ones. 2 times negative 1 squared minus 4 times negative 1 minus 4. 2 parentheses negative 1. Square it. Minus 4 times negative 1 minus 4. Did you guys get 2? All right, so that's exactly what I got, right? 2, negative 4, negative 6, negative 4, and 2. Remember, since it's a parabola, you got these guys are the same output. Okay? Now, I need you to graph this. 1 comma negative 6. 2 comma negative 4. I want to draw my axis of symmetry as well. And then 3 comma 2. 1, 2. There you go. It's a mirror reflection, so I went 1 to the right, 1 to the left. I went 2 to the right. I'm going to go 2 to the left. And it's a smiley face. There you go. Vertex is that number that you found, 1 comma negative 6. Axis of symmetry is that first coordinate, the x coordinate of your vertex. And obviously it's an equation, x equals 1. When you are ready, turn the page. These ones, I'm not going to lie, 7 and 8 are pretty easy if you know what's happening. Our parent, I always look at what's happening inside the parentheses, and we move in the opposite direction. So our vertex goes, since it's plus 6, x plus 6, our x's are going to go to the left 6. Vertex goes to the left 6 units. And since we have a minus 8 outside, that goes, vertex goes down 8 units. You see how the word left and down, right? Left is with the x's and the y's are with like up or down. And then we have a -3. That means we're having a nice little, our outputs are getting nice and stretched out. The vertex, since you moved left, your vertex, okay, -6, because you went to the left, because usually it's at the origin, and then you went down 8, so -8. -6, -8. If we look at number 8, same thing. We look at, I always start with inside the parentheses. It's just easier for me. X minus 3, oh, we do the opposite. Instead of left 3, we're going to do right 3. And then there's a plus 5. So that means we're going to move up 5. And that's it. So we move to the right 3, that's positive 3, and then up 5, 3, 5. So you're here at the origin, and if it tells you go to the right 3, 1, 2, 3, and then up 1, 2, 3, 4, 5. So this is like a little visual, right, of your vertex.
So does the first number, like 1 number 7, does not matter?
The first number, correct. This little guy, the one that the -3 in this case, it's not that it doesn't matter. It doesn't matter for the vertex. But when you graph it, it does matter. Because it creates a stretch. But yes, very good job. The number in the front doesn't matter when you're determining the vertex. Let's go to number 9. We got to graph the following quadratic function using transformations. All right, let's do that. So our parent, it's important for you to write this down in your flashcard. You got your x and your y. Our parent is always y equals x squared. You're always smiling at the origin. I always say, hey, you're a smiley, wily person today because you're so happy from the bottom of your heart, from your origin. We always use -2, -1, 0, 1, 2. So this is a table that you should have. I'm going to go ahead and put a cloud over it. You should have this in your flashcard. Anything that I put a cloud over, you should probably have in your flashcard. 4, 1, 0, 1, 4. Okay? How does this work? Okay, so what we're going to do is we're going to focus on what we're doing. We're doing opposite. -2, that means we're going to add 2 to the x's. The x's are moving to the right too. And since we have that +3, we're going to move our y's up 3. So this is y plus 3. Can we do the math? 100%. All these guys are going to be pretty much copy-pasted over here. So -2. I'm taking all of my x values, and what I'm going to do is I'm going to add 2, add 2, add 2. And I'm going to take all my y's, and I'm going to add 3. There you go. And let's do the math. Usually I do it in the same page. Usually I do it on the same table. But what I'm going to do is I created a final table. Oh, yeah, I have it. -2 plus 2, that makes 0. 1, 2, 3, and 4. And the other one is 7, 4, 3, 4, 7. And this is your final one. This is your x, and this is y equals. This is your transformation one. There you go. Pretty cool. So the one that we're going to graph is our final one on the graph. Okay, so here we go. So it's going to go 0 up to the 7. Put a dot there. 1, 4. 2, 3, you can draw your axis of symmetry there, and then 1 point to the left, 1 point to the right, and there you go. It's a nice little pattern. It's a nice little smiley face. And it wants us to find the vertex, whether it's a min or a max, y-intercept, and everything else. So let's do that really quickly. Vertex, we know, is right in the middle, 2, 3. Move to the right 2, up 3. It's a smiley face, so we have a minimum. What's the y-intercept? It's just we look here and it's just 0, 7. Okay. Our domain is always the same, negative infinity to infinity. Our range from bottom to top, 3 bracket to infinity. And do we have any x-intercepts? None. And that's it. None. All right, so let's go ahead and go on to the next page. This is where it starts getting a little bit more exciting. Oh, well, actually, after number 10. I think I have, there you go, okay. So for this one, I'm just going to copy paste my parent function over here because this is something that you should have already memorized or in your flashcard. So here you go, paste right there. I pasted the parent. Very good job. And now I have to focus on this. Okay, so I add 3. So plus 3 to the x's, but I do opposite. I do my x minus 3. All right, this is a plus 5, and in the y's, we do that, plus 5, but we have a minus 2, so our y's get stretched out. So let's go ahead and do this. We got negative 2, negative 1, 0, 1, 2. We're taking our x's, and we're taking away 3 to all of them. For our y's, I'm going to leave a little bit of space. I am going to multiply by negative 2. And then I'm going to add 5. Perfect. So what I'm going to do now is I am going to do the math. That's negative 5, negative 4, negative 3, negative 2, negative 1. Those are my x's, and this is going to be my transformed one, which is negative 8 plus 5, negative 3, negative 2 plus 5, so negative 2 plus 5 is 3, and then we got 5, and then we repeat. Yeah, are there any questions? And this is the one we're going to graph, okay? Maybe if it helps visually. Okay. Negative 5, and then down 1, 2, 3. Negative 4 up 1, 2, 3. Negative 3 up 5. 1, 2, 3, 4, 5. And then we just follow the pattern, okay? Draw your axis of symmetry. And there you go. There you have it. All right. What's our vertex? Our vertex is negative 3, 5. Smiley face or frowny face. We have a frowny face, so therefore we have a maximum. Our y-intercept that we calculated, bless you. If we continue the pattern, right, y-intercept is at 0, negative 6. And to be exact, we replace, oh, actually, to be exact, if we were to do this, we would replace the x with 0, because for the top one, I think we should be exact. Replace the x with 0. For the y-intercept, we're going to do y equals negative 2x plus 3 squared plus 5. Negative 2, 0 plus 3 squared plus 5, just replacing the x with 0. Negative 2 times 3 squared plus 5. Not that you need to worry about this, right? Because I'll give you easier ones on the exam. And this is negative 13. It actually crosses at negative 13, but you don't need to worry about the y-intercept when you're doing this one. I will give you easy ones. The domain's always the same, and the range is from negative infinity all the way up to the highest value, which is a 5. Do we have x-intercepts? Why, yes, we do. I don't want to get too into the x-intercepts, right? So let's skip that one because they're not exact. So we're skipping the zeros and solutions there. All right. Now, we did do the gallery walk in class, right? So the colorful papers are still up on the boards, which is great. But we need to classify the following by degree and number of terms. And I think a lot of you did that, right? Look at the number of terms, 1, 2, 3. And then always circle the highest exponent, which is a 2. If your highest exponent is a 2, that's quadratic. And it's 3 terms, trinomial. Quadratic trinomial. Highest exponent is a 2, so that's a quadratic. And then since there's only one term, it's a monomial. Turn the page whenever you're ready. All right, now we're working with number 12. Write the following polynomials in standard form and identify the leading coefficient. Okay, first of all, standard form, you got to look at the exponents. You go from largest exponent to smallest. There's an invisible 1 here because there's only one x, and that's it. So start with the largest, negative 8x cubed, right here. Minus 3x, right there. And then plus 5. Boom. What is your leading coefficient? Your leader number is negative 8. Let's do the next one together. X to the power of 3 goes first. Then comes x to the power of 2. Then it goes to the power of x, minus 5x. Then at the end, it's minus 4. The leading number, oh, it's invisible, Miss Sanchez. It's just 1. The leader number. When it's just x squared, x cubed, it's just the leader number is 1. Call it the leader number, but it's the leading coefficient. Are there any questions? All right, now number 13, you got to add. So how do I do this? Well, it's kind of like I told you guys it's like a drawer. Always put all your x to the fifths together, all your x to the thirds, all your x's together. All right, let's make a drawer. I know the highest exponent is 5, so x to the power of 5, that's my first drawer. Maybe I should make this a little smaller. X to the power of 5, there you go. My next drawer is, what's the next exponent I see? Oh, x to the power of 3. Okay, what's another drawer? Okay, 5, 3, but then I have ones. Okay, good. So I'm gonna go ahead and organize first my pink terms. That goes here, so that is 4x to the power of 5 minus 3x to the power of 3. And then I have my next terms, and it's adding, plus 2x to the power of 5 plus 5x to the power of 3, my ones. And I add or combine like terms. 4 plus 2 makes 6, so we get 6x to the power of 5. Minus 3 plus 5, that is a plus 2x to the power of 3. And then minus 6, just bring it down. So your final answer is 6x to the power of 5 plus 2x to the power of 3 minus 6. Are there any questions? Now we're going to go to number 14. It's subtraction. I always, like to remind you guys, add by the opposite. So first you add, and then opposite, change signs. So add by the opposite, and then change the sign of all of these guys. There you go. Okay, sweet. So now we're going to go ahead and do our columns. I'm really good at doing my drawers. Setting it up, x to the power of 3. X squared. Oh, these are w's, right? W to the power of 3, w squared, and I think just w. Organize them, okay? Make sure you're writing this down. So you get 10w to the power of 3 minus w squared. And then you have these guys. down here. Stack them one on top of the other. 2w to the power 3 minus 3w squared plus 5w. Combine like terms. This is 12w to the power 3 minus 4w squared plus 5w. Your final answer, therefore, is this guy. Okie dokie. Now we're going to move into the fun ones, which I love, which is multiplication. And I always think about base times height, okay? This is a 1 by 2 box, okay? One term, two terms. So 1 by 2, okay, 1 by 2 is like this, okay? So this is where I put my 2x outside. Whenever you see parentheses, those are your numbers outside. Multiply them together, right? 2x times 5x is 10x squared plus 6x. Therefore, your answer is your area inside here, which is 10x squared plus 6x. And you are done. Do you guys have any questions? It's always good to know how many terms are here. 2 by 2. 2 by 2. So create a 2 by 2 box. How do you create a 2 by 2 box? You go like this, and then you go like that. So x tiles, and then your 1s, x plus 2, x tiles, and then your 1s. Okay, doesn't matter where you put them, as long as you put them on there. X times x is x squared, x times 5x is 5x, 2x, 10. What's your area? It's everything inside, right? When you multiply, it's everything inside. X squared. Now what am I going to do with my diagonal? Does anybody know? When you have 5x and 2x, add them. That makes 7x plus 10. And you get a nice little trinomial, 3-termer. All right, let's go down to 17. What are we going to do? Same thing. 2 terms by 2 terms. Create a nice little 2 by 2 box. See if you can do that. There we go. Yeah, it doesn't matter how you make it. It doesn't have to be perfect. 4x squared, and then your 1s, and then your x, and your minus 3. Check your math. 4x squared times x is 4x to the power 3. 4x squared minus times negative 3 is negative 12x squared. Positive x minus 3, and therefore you get your area as everything inside. 4x cubed minus 12x squared plus x minus 3. We were not able to combine any of the like terms. Or, sorry, we weren't able to combine any of the terms because they're not like terms. When you are ready, turn the page. Okay. All right, here we go. So again, this is just repeated process, right? We're repeating the process. I'm going to go ahead and do these. All right, we have a few more minutes. All right, this is a 2 by 3. So create a 2 by 3 box. I would kind of, since it's 2 by 3, divvy it up into 2 parts and then 3 parts. Okay, so 2x and your 1s, 3x squared minus 5x minus 2. Here I go. This is 6x cubed, negative 10x squared minus 4x. 3 times 3 is 9x squared minus 15x minus 6. Look at your diagonals. What do you notice? Anybody? They're like terms, so we can combine them. Good job. And it's better to do it in your head or in your calculator. So first, write down the top left number, 6x to the power 3. But then what is 9x squared minus 10x squared? You're left with negative 1x squared. What is negative 15x minus 4x? Negative 19x. And then don't forget your 1s, bottom right. Boom, that's it. Okay, number 19, it was on one of those colorful papers. The base, you see it twice. So x minus 4 times x minus 4. So this is a 2 by 2. 2 terms times 2 terms. So if you want to draw it like this, you can. Let's draw it over here. Okay, there you go. X minus 4, x minus 4. X times x is x squared. X times negative 4 is negative 4x. You get the same thing here. And there you have it. You combine like terms for the diagonal and you get x squared minus 8x plus 16. Are there any questions? You guys should be writing these down. If you already worked on them, you should be checking your answer and making any modifications if needed. Number 20, this one's a nice one. I like this one a lot. It's a 2 by 2, but something interesting happens with the diagonal. So x plus 3, x minus 3, x squared minus 3x plus 3x over here, but minus 9. What do you guys notice about the diagonal?
Cross cancel.
They cancel, right? Negative 3x plus 3x, it's opposite terms. So all you get is x squared, technically plus 0, but we don't have to write that. So we just put the one spot, the negative 9 right there. Because this cancels. Or, in other words, it's a 0 pair. So it's 0. All right, we're going to go ahead and do 21 and 22, and we'll go on a short break. So find the area of the rectangle. Again, area just means you're going to multiply, and that is something I want you to put in your flashcard. Area means multiply. 2 terms times 2 terms, so 2 by 2, same thing. 2x minus 1, x plus 6. So you get 2x squared plus 12x minus x minus 6. Again, combine like terms with the diagonals. 2x squared plus 11x minus 6. And that is your final answer. Just that little area right there. Number 22 is going to be on the final, and it is not that, I mean, all those questions are going to be like similar to the ones on the final, but this one is like, I think the one that is the most commonly missed. So if we look here, we got to find this area of the outside, of the bigger rectangle, and then find the area of the smaller rectangle. The only way to do this, the only way to find this area in here is if we take bigger area minus smaller area. Yeah, sorry. The only way to get this little guy is to find the area of the big guy and subtract it by the smaller one, okay? So this is what we're going to do. Find the area of the outside, 2 terms by 2 terms. Okay, I can do this. 3x plus 5, x minus 4, 3x squared minus 12x plus 5x minus 20. And we get 3x squared minus 7x minus 20. So this is big rectangle. What about smaller rectangle? Well, let's see. What about for smaller rectangle? I have 2x, so a 2 by 1 or 1 by 2. 1 by 2. So here I go. Since it's a 1 by 2, I'm going to go like this. I'm going to put x plus 1 here and 2x here. 2x squared plus 2x. And therefore, we get this little guy. Not a big deal. Now that we got small rectangle and big rectangle, what we can do is subtract, right? You're going to take big minus small, which is big is 3x squared minus 7x minus 20, but then minus the small one, which is 2x squared plus 2x. Remember what I said about this is adding by the opposite. Add by the opposite. Boom. So we take, now let's make our column 3x squared minus 7x minus 20. But then we're going to stack this guy on top of that guy and this guy on top of that guy. Right? It's a little column. So this makes x squared minus 9x minus 20. And that is your area of the shaded region. Are there any questions? I think this is probably the part that the most people miss. is big rectangle minus small rectangle, and make sure you do add by the opposite, right? Change that minus to a plus, and then every term flips signs. Okay, and then create a nice little organize terms. And then add or combine. Okay, what we're gonna do now is turn the page. We are going to start factoring when we get back from the break. We're gonna stay inside. So number 23, here we go. We have to factor. Since it's only 2 terms to factor, I always tell my students it's pretty much just 2 terms inside of the box, and it's okay to put them inside a 1x2. What is the GCF here? We take out a 3. They're both divisible by 3. So you have to work backwards. So this is x squared and -7. Your answer is therefore the outside numbers. You're trying to find the factors. 24, same thing, 2 terms inside of the box. Find the outside by using GCF. They're both divisible by 3, and they both have an x. So this is 4x, and this is plus 5. So your answer is 3x times 4x plus 5. Now we have number 25, which is, they're y's, but it's okay. We're usually work with x's, but y's are the same. It's 3 terms. I am going to use my x and my box. Top number is a times c over b, and then the bottom is b, sorry. And that's 21, and then the bottom is -10. You gotta multiply to 21, add to -10. So here we go. 7 times 3 is 21. And you need them to both be negatives because you need to multiply to get a positive, and you gotta add to a -10. So this is where your -7y, -3y go. Y squared goes top left, and 21 goes bottom right. You find the GCF here, which is y times y times -3, and -7. So your factor is your factors are y minus 3 and y minus 7. Are there any questions at all? Okay, let's go on to 26. 3 terms. Again, you got to practice your x in your box, and we did that a lot when we were walking around the classroom. Top number is a times c, which is 8, and bottom number is your b, which is +6. 4 times 2 is +8, and you add to 6. So this is 4x, 2x, top left, x squared, +8, x times x, +2, +4. X plus 2 times x plus 4 are your factors. Any questions? 27, we got a factor. Okay, same thing. I feel like this is just repetition, but I'm going to do it again. -24, a 10, and we get 12 times 2, but we need a negative, okay, and we need a +10. So it's 12 times -2 is a -24, and then you add to 10. Those go in the diagonal, and top left is x squared, bottom right is -24. So this is x times x minus 2, and this is oh, sorry. I think I might have, yeah, there you go, 12. It's a positive. There you go. So your factors are x minus 2 times x plus 12. Doesn't matter the order that you write them as long as you have them there. One more, number 28. We're going to go ahead and have our a times c and our b. A times c, a in this case is 3 and -18. Okay, 3 times -18 is -54. and your b is a 3. Okay, so now this is where it starts getting a little tricky. You need to know your multiplication facts. And we know 54 is 9 times 6. And you do 9 minus 6, that gives you 3. So that's a really good one, 9 times 6, but one of them has to be negative. The smaller one has to be negative, of course. And we use our box. And a lot of students ask me, well, which one goes top left? Always your first term, your leading term. 3x squared, bottom right is your c value. And your diagonal numbers are these guys. You split up, right? You split up your negative 3x, your 3x. 9x minus 6x. You always find a GCF, right? We always do that. And we get 3x, and then 3x, and then times x, minus 2, positive 9 here. And there you go. A lot of students ask me, well, Miss Sanchez, we didn't take out a GCF. We didn't even consider a GCF. I said, no, you don't have to. As long as you focus right here. So we didn't take out a GCF. We could have, right, because the numbers are pretty big. But look here. Do you notice a GCF between 3x and plus 9? What number are they both divisible by?
3.
3. So take out the 3, put it at the very front, and keep your x minus 2 there. What do you get when you take out a 3 here, when you divide both by 3? X plus 3. And you just bring that little guy to the front. So even if you missed a GCF in the beginning, you can still take it out at the end. And it's something that, it's a skill I want to teach you, okay? Obviously, you could have done that from the beginning, but I kind of was like, these students are really, you guys are very smart and you guys know what you're doing, and I know that I can take out a GCF at any time. As long as I do it, right? You can't forget. Turn the page when you're ready. Now for 29, I'm going to show you how to do it when you do take out a GCF from the beginning, and you'll see that we get the same exact answer. You guys ready? All right, here we go. So let's take out what's they're pretty big numbers, and we see that they're all divisible by 2. So why don't we take out a GCF of 2? If we take out a GCF of 2, that means it goes in our final answer. So there's 2. But then we get to see what we're left with. So 2 times and divide it. So that's x squared minus 8x plus 7. There you go. So we see that we took out a 2. We put that in our answer, which is awesome. Very good job. Now what we need to do is factor this guy. Bless you. So use x in box here. 7, negative 8. 1 times 7 is 7. And we want to get a positive, and we want to add to a negative. So negative 1 times negative 7 is a positive 7. And add to negative 8. So this is just really, we've done this. It's repetitive, but we got to practice. X times x minus 7, negative 1. So we notice that our factors are x minus 1 times x minus 7. But we can't forget about our GCF. That goes in our final answer. Does that make sense? You could have easily started with the x in the box, but obviously you always had to take out a GCF. Any questions at all? Are we good to roll on to the next? All right, cool. Let's do number 30. Same thing, but this time there is no GCF, so we just have to go straight to the x. 12 times 2 is 24. 11, so two numbers that multiply to 24 add to 11. Anybody know? 8 times 3, good job. And we go ahead and create our box. 2x squared, 8x, 3x, and then positive 12. Find your GCF, 2x, and that gives you an x, plus 4, plus 3. And your factors are 2x plus 3 times x plus 4. And those are your answers, or your two factors. All right. Do we have any more? Okay. Okay. Let's go with this next one. Same idea, no GCF. That's a -10, and that's a -3. All right, two numbers that multiply to -10 and add to -3. What do you guys think? 5 times 2, right? And you need a negative number, so make the bigger one the negative. Slap them into the box. You get 10x squared here, minus 5x, positive 2x, minus 1. Get GCF, 5x, times 2x, minus 1, plus 1. So 5x plus 1 times 2x minus 1. And there you go. Those are your two factors. Wow, we're getting through this. Lots of factoring. Number 32. We got to do a difference of two squares. But a lot of you are like, what is that? What's the difference of two squares? Well, you know what? If you forget, just use your box. I always like to do this if we have m squared inside and we have -6. You have your ones and you have your top left, which are your x squareds. So now we got to find, since they're both perfect squares, right? 64 is a perfect square. And so is this guy, perfect square. That means that the diagonal numbers canceled out, right? Right, because we have a negative. So what we can do is m times m is m squared. Now, what are two numbers that are opposite signs that multiply to -64? -8 and +8. So this is 8m and -8m. And do you guys see how these guys cancel out? So you don't even have to, they're technically non-existent, right? They don't exist in our equation. So we get, therefore, our factors are just the m plus 8 and then m minus 8. There you go. No big deal. You notice that they were both perfect squares. And we were able to do this. And there was a minus sign in between, right? The two squares. Oh, let's look at this guy. Are these guys perfect squares? Both of these. What do you guys think? Yes or no?
Yeah.
Yeah, just put them top left, right here. They're both perfect squares and there's a minus sign. So all I have to do is, okay, they have to be the same number. 3x times 3x. Have to be the same. They're squares, 3x times 3x. But now two numbers are the same but opposite. +7 minus 7. So does that make these guys cancel? Does the diagonal cancel, guys? Yes. And so therefore our factors are just 3x plus 7 and 3x minus 7. Because they're both perfect squares. It's kind of neat, huh? Because the diagonal just cancels out. All right, let's go down to number 34. All right, 34. This one's kind of nice because they give you 4 terms. Whenever they give you 4 terms, you're like, oh, 4 terms is a ginormous box, and I'm going to go ahead and put them all, slap them all into the box. Doesn't matter how they go. There you go, as long as you take the GCF correctly. They both have they're both divisible by 3, and then they both have x squared in common. This is 4x minus 1. And this is going to be minus 5. There you go. Therefore, you get these two are your factors. The dimensions, the numbers outside, right there. Are there any questions? Can we go on to the next?
Wait, can I set the whole page real quick?
Yes, of course. Yes, of course. This video will be posted online as well. When you're ready, turn the page. You okay?
Yeah.
Okay. Now we've gone to unit 7. My goal is to get to number 40. So let's get started. So solving quadratics is easy as long as you know how to factor, right? So solve by factoring. Again, 3 terms, x and then box. -8 and 2. This is 4 times 2. And and you put those two numbers right there, and then your diagonal numbers are these guys. These are your x's. 4x minus 2x. And your GCF here is x times x, and there you go. So you found your factors, x plus 4 times x minus 2. But don't forget, since this is equal to 0, your y's are equal to 0, so that means you have x-intercepts. You got to find out. Okay, Ms. Sanchez, I know when you multiply two numbers, one of them has to be 0. Okay, here's case 1. X plus 4 equals 0. What does x have to equal in order for this to be a 0? For the first parenthesis. There you go, parenthesis group. X has to be negative 4 in order for this to work. What about the other guy? X minus 2 equals 0. No, let's use a different color. What does x have to equal in order to make the second group equal to 0? Second parenthesis group, x has to equal 2. So just, I think someone said, oh, just change the sign of the number. Yes, okay, so that's essentially what we're doing. Your two x-intercepts are x equals negative 4 and x equals 2. Let's go to number 36. We have x squared minus 3x minus 40. Same idea, right? You got negative 40 on top, negative 3 on the bottom. What are two numbers that multiply to negative 40 and add to negative 3? Anybody know? Negative 8 and 5. Very good job. Because it's equal to negative 40, right? When you multiply them, and then you add to negative 3. Good job. Put them here. X squared minus 40. And you're going to have negative 8x, 5x. Find your GCF. And there you go. This is neat. X minus 8. X plus 5 equals 0. You get two cases. Oh, the first parenthesis group. X must equal. Add 8 to both sides. You get x equals 8 for one of them. The other one's x plus 5 equals 0. Subtract 5 to both sides. You get x equals negative 5. So you do get 2, right? X-intercepts. It's always good to know that. Questions? Okay. Now let's look at, you can always pause the video when you're doing this. Find the solutions by completing the square. I had a student last period, or yes, last week, was just like, do we have to use completing the square? No, you don't. You could use a quadratic formula if it makes more sense. I'm going to go ahead and just do just because it says completing the square, I'm going to do it that way. I'm going to subtract 3. That's the wrong number of ones that they provided me with. So I'm going to do x squared plus 2x plus the missing number equals negative 3. I know I have x squared tile, and then I have 2x, 2x. A lot of students don't like the tiles. They'd rather just use the box. I said that's fine. You got to make sure, since you're building a square, this has to be x squared, and there's an x and an x. So you had to split up 2x into half, right? X and x. This is x, plus 1, plus 1. Therefore, the number of ones missing is a 1. You're going to add 1 to both sides. What are the factors here? Are the outside numbers. X plus 1 squared equals negative 2. And then you take the square root of both sides. And you notice something. You can't take the square root of a negative. So that means there is no solutions. No x-intercepts. Whew, we're almost there. Number 38, solve by completing the square again. Okay, let's do it again. So x squared plus 6x plus blank equals 16. Let's use our box. X squared, split up the x tiles, 3x here, 3x here. Find your GCF, x times x, and then plus 3 plus 3. The number of ones that are missing are positive 9. So add 9 to both sides. The factors here of this guy are x plus 3 squared equals 25. Now we are able to take the square root of both sides, and we get x plus 3 equals plus or minus, and square root of 25 is 5, because 5 times 5, right? Now you get two answers. You get x plus 3 equals positive 5, x plus 3 equals negative 5. Excuse me. So what I'm going to do is I'm going to subtract 3 to both sides, and you get x equals 2. Subtract 3 to both sides over here as well, and you get x equals negative 8. So you box in your answers, and you say, hey, we have two x-intercepts, x equals negative 8, and x equals 2. I had a student say, can I use quadratic formula? 100%, but you have to make sure that you do this. You subtract the 16. It has to be in standard form. Okay? Standard form means you have to have it in ax squared plus bx plus c in order for you to use quadratic formula. Which leads us to number 39, which is the quadratic formula. You need to have this guy memorized. But since I'm giving you a flashcard, you don't have to have it memorized. You simply write this in your flashcard. Again, I'm putting a cloud over it. You should have that in your flashcard. Let's substitute. X equals negative parenthesis, negative 6 plus or minus. And then negative 6 squared minus 4ac all over 2 times 3. So a equals 3, b equals negative 6, c equals 1. You get 6 plus or minus. You plug this into your calculator, just the inside. Sometimes you'll see that it makes your life a whole lot easier when you just start there. And you get 24 over 6. I had a student mention, hey, Miss Sanchez, I don't know if this is how you want my answer to be. I said, you know what? On the exam, I'm going to make it even easier. So right now I'm going to show you how to simplify that. Because we know what 24 is. It's 6 times 4, and 4 is a perfect square. So yes, I would like for you guys in the future to simplify. But, and this would be splitting it up, 6 over 6 plus or minus 2 rad 6 over 6 equals 1 plus or minus rad 6 over 3. Thank you. So essentially, don't worry. On the exam, I'm going to give you a problem where you don't have to simplify the radical. Okay, so there you go. Let's go ahead and review for